Well, today I'm going to continue the chat application. Rest assured if you have issues following me through the coding, because I'll leave my GitHub repository in the description below. And today will be a very important one because I'm going to start the communication between the client and the server side, and there will be a lot of refactoring going on. Also, from the HTMX side, there's a very important tag from the issue that I faced last time. So last time, I was able to send the message from the server to the client side. However, I could not patch any CSS style or even the division into the content, into my element. So that is an issue related to HTMX. I'm not sure if this is an intended behavior, but eventually I found that this is the reason. Well, let me show you. Firstly, my chat room is essentially a div with the ID of chat room, as you can see right here. And my message is a P that will swap every time when the server sends the element in. It will then swap into the chat room division, and it's before it ends, so it's a last children of chat room. Logically, it works, but there is a very important mistake that I did here, where instead of the P, I need to put in as a div. Maybe, I'm just saying that maybe it is because my chat room is of the tag div, so here it has to be div as well. And then inside there only I can put in like this, P. I've tried many ways, and this is the only working example where I had to change the parent into the division. Then only my style or anything inside can be patched. As you can see, now it works perfectly with the color and the styling that I set. Alright, then now we are going to do refactoring so that we can keep our connection cache in our memory. Reason being, whenever any client using this socket connection to join our chat, we need to be able to, like when imagine there are more participants coming in, we need to be able to broadcast our message to all the participants in certain chat rooms. So with that being said, I cannot just simply handle for separate clients at once. They have to, the server has to know all the connections, who is who. Okay, to enable that, there will be a lot of refactorings needed. And firstly, it's going to be we want to aggregate everything into this manager type. So first of all, it's going to be a struct, and inside it's going to be a client list where we store our list of clients inside the file. And we also have a client.go where we have a client struct that's in charge of managing an individual client. So firstly, it's going to be like setting the content needed into in our client. So let's refer to the connection. Right, the connection, when we get the connection, we name it as WS, right? So we want to inspect the type here is websocket.con. So we just copy this and make sure that the connection is here, websocket.con. And definitely we want to make it package main because it's in my root folder, and it's not the WebSocket that I'm expecting here. I need to use the Gorilla WebSocket instead. Right, with the connection, we can also have other things that this client can hold, including like its say user or whatever things. So for now, I'm going to put in a chat room, and it's going to be a string, and it's an ID as well, and also the manager. So I can always have a pointer to my manager to do the operations. So client can sort of like call the manager's function to do any required operations in the future. So the client has been done. Here is going to be a list of client, and then we also have so it's a uppercase, so it's a public variable. Secondly, what the manager needs to have is let me think. Well, we can add it in the future. So for now is the manager has to also have the functions to join chat. Basically everything inside here, I want to wrap it with a manager. And the client list is an array of clients. It can be also as in a map depending on the data structure that you want. I believe array is the most straightforward when we look at it, but it may not necessarily be the most efficient one. You may want to consider map or other data structure depending on your requirements. But for the demonstration purpose, I'm just going to stick with array for now. Right, coming back with the main story. So what my manager do is, firstly is a constructor. I need to use this constructor in my main.go file to initialize my manager. So it's going to be returning a manager here, and then I will return an manager object with a client list of a list of client. And first thing manager is going to be serve the HTTP, so I'm going to name it handler. So this handler is essentially replacing the entire join chat function, which means that we can straight away copy the entire function right here and then do the operations needed. Alright, so now we have put in everything right here. We also have the client ready now, and then what I want to do is I want to deprecate the join chat. Okay, just deprecate this thing, and inside my main function, I'm going to add in the manager, initialize it equal to new manager, and then here is going to be manager.handler. Alright, so I'm passing everything from the logic to be handled by the manager struct instead. So when we replace it, refresh the page, we get the exact same results because I'm just refactoring the function and encapsulate into the manager struct function. Okay, exactly the same behavior. Next, what I'm going to do is I want to initialize the client, like create a client, and make sure that the client can always read and write messages. To do so, I can have a function that is handled by the client called read messages, and I can also have another function that is write message. Okay, so these two I will implement it afterwards, but in our handler function it's going to be important, as in it will let me think, what is the first thing that I'm going to do. Right, so manager, right, it also have to, because this is a list of clients, but the connection may come in concurrently, which means that we cannot simply say that from here, right, okay, do this, okay, let me create this function, helper function, so that we can always initialize new client with this constructor. So the connection is the connection parameter that we pass in, and it's websocket.con because this ID is going to be uuid dot uuid dot new dot string. Chat room is going to be a general, and then we also pass in the reference to our manager right here. Alright, so in our handler manager, I'm going to initialize a new client equal to new client and then the connection is the WebSocket, and then our manager, we just pass in the M, reference to the M, and new client. Okay, because remember what I'm saying, whenever there is a new client coming in, we want to keep the list of clients, right? But we cannot assume that this is a thread safe operation. So what I want to do here is I want to create a sort of like a channel, like a queue, and my backend will process this the operation on top of the client list one by one. Let me do it in action so it's easier to see. Firstly, initialize the type of new, say this is a client list event struct. It is a client event type. I think it will make sense afterwards for you. And rest assured, if you have issue following me right now, okay, let me just say it out first. Okay, so we have a client list event, and then manager, we also have a channel. So here is a client list event channel that is on the channel of client list event, like this. Okay, well, I guess the setup should be, let me just put a star here, so it's a pointer to the client list event, and the channel is a map of a channel with a comma right at the end. Okay, so this event channel is going to be the queue that handles the operations, like we want to add in the new client list, or we want to remove the client from the client list, to make sure that the operation is synchronous, as in we don't want the two different places to modify our variable at the same time and end up causing like weird issues in terms of a concurrency issue. Okay, so I have a helper function, new manager, manager, that is, say, handle client list event channel. It's kind of long, but yeah, you get what I mean. Like, I have a for loop, and then from here, let's say select. Here I can put in the like context, dot context. Or maybe I can say that it is a context dot context, like this. Okay, so select client list event, okay, from the channel, and the channel is coming from our, where is it coming from? Okay, manager dot client list event channel shared. Where is my oh, okay, it's a case, I forgot the case. Right, like this. So I'll get in the data from the client list event channel, like feed in one by one. If it's not okay, then I will just return it. I can do the error handling, but afterwards. Okay. And then I do the switch client list event dot event type. And the case of, say it's add event, then I will add in the m dot client list equal to append m dot client list m client list event dot client shared. Okay, then I'll break it. Or case, if it's a remove, then I will remove it from the list. new slice equal to client list, and then m dot client list equal to new slice for client in the list of m dot client list if client dot id equal to m dot client event client list event dot client dot id. Continue. Else I'm going to say that new slice equal to append new slice with our client. Alright, so we just handle this client list event channel with say two cases. One is when it is adding, then I'll add into the manager client list. If it's removed, I'll then remove from it, and this will ensure that it is a thread safe operation by putting all edit operations in a queue. Okay, and secondly, we also have a what I did just now. Shared. Okay, this is a switch, and below here, it's probably going to be add in another context.done. Then, if it's done, I'll return everything. Alright, like this. Okay, so it's an infinite loop that will handle the client list event channel all the time. And we just pass in the context will do. And in our manager here, we initialize the Go routine to handle the event list channel, and we pass in the context.background like this. Okay. Well, this is my honestly, right, I'm not 100% sure this will work, but I feel like it will work. So let's experiment together lah, right? So here I created a new client already. The next thing that I want to do is I want to fit in the event list, this thing, the client list event to our channel. So m dot client list event channel fit in our event list client list event with the client of new client, and the event type is add, like this. So I ensure that the new client is added into the client list, and then I will say that the new client, please start reading your messages and please start writing message. So these are the two different Go routines that we will be using it soon after. And let's return a new. Alright. And this entire thing, they are in the new client that read message and write messages that I will be implementing afterwards. Right, there's no need to use a break, is it? Okay, that's quite interesting. Do I not need to use a break? Does it continue? I don't know. Golang switch break. Oh, that's okay. So switch is not needed, right? Okay. It's not needed in the break is not needed in Golang. Okay. Interesting. Well, coming back, right? Every time when the client connect to our server, the first thing we are doing is we are adding it to the client list event channel, so that our manager get the latest list of clients. Secondly is we will initialize two Go routines. One is to handle the read messages, another is handle write messages. And now it's time for us to implement the read and write. So I'm going to paste these two important block of codes so that we can reuse them. Okay, so write is not needed in when we are reading the messages. Okay, when we are reading a messages, right, it's going to be a infinite loop where we can say that it is c dot con dot read message. So you read the message, and here probably I may want to pass in the echo dot context as well, so I can do a logging like this. So it's ctx. So ctx dot logger dot error and all this, standard thingy. Just putting the echo context right here, and then every time it will loop, and if there's an error, I would just want to return, and if not, I'm going to pass in the message to write. So this is to pass into the client, but remember we want to defer. Whenever there is a error in any parts here, we want to defer and close the connection. And we don't need to use it in here already. The defer that we initially put in the handle, right, it can then be handled inside the client itself, like this defer function. And why is it having so many parameters on? Okay, like this. And then c dot connection dot close. We also want to pass in, remember just now, the c dot manager dot event list channel. Now this is where the reference to our manager comes into play, because we want to tell the manager to remove our client from the client list now. So we want to create another event, client list event, with the type of client is C, and our event type is remove. Okay, so whenever there is a connection loss or due to any errors, I just close the connection and remove it from our client list. Same goes to writing. We also want to enforce this mechanism to do the checking. Alright, so reading is done. Whenever there's a new messages read by the backend, we want to make it able to write or broadcast to everyone else. So that is the goal of the day. And to do that, we can use the similar concept of channel, where we have a specific channel that is for writing messages. So it can then avoid or prevent any situation where concurrent writing happens and causing any weird behavior from happening. With that being said, I can say that this is a message channel, and this is going to be a channel of string, and the message channel is going to be making a channel of string. Okay, and this message channel is in charge of channeling the data to the backend to write to or to broadcast to other people. Okay, and we can use this message channel, pass in the string of the messages as a data. Right, this is that's all for reading a message. How about writing? Okay, writing is also depending on the if we have things that we want to write, and that is we can use a select. Okay, context.background context.background done. Let's try this. Okay, I still need a context here. I wonder if a context.background does work though. Okay, let's try. First thing is, when we are writing the message, we want to use a select operation, and listen to the text from the client channel. Okay, again, I forgot. Whenever I use a select, I'll need to use a case. Let's channel the data in. It's called message channel. Okay. And from here is like this. If not okay, then return. Else, I will do the writing messages right here. And then if it is okay. Okay. This is a call context. And probably I can pass in the CTS as well, context. And then if it is not done. Oh, I can do like this. Okay, return. Okay, if it's done, then I return. Maybe I don't need this. And here I continues use the CTX. Okay, so two conditions. Whenever there are new messages, I want to write it to all the clients, right? So components can do like this, and then here is wait a minute. If I want to broadcast the message, right, I feel like it means that I can. Okay. Anyway, this is a buffer. Render the text and then write the message to the client. And here is a context.logo.error. And finally, the thing I want to do is, whenever there is a message, I want to write to all the clients. So probably it's going to be from for client in the c.manager.client list, and I'll do the write message here. client.con.write message like this. Alright, I guess I am done. But this way of writing the messages, right, I feel it's not a good way, because when there is any error, it may cause the thing to be okay lah. For now I put it right here. I think it will work, but it may not be the optimal one, because say for the relationship between client, right, it's not supposed to be able to control other clients one. But with this way of writing, I think it means that it will control other clients. Well, I'll fix this structure in the future, but for now I keep this as it is to make sure that the logic is working. Okay, coming back to the let me check if I miss out anything. Alright, reading messages and writing messages. Oh, okay, one more thing is, in the manager I can also add in, if it exists already, I just want to return in the range of m.client is, and then if client.id equal to client list event.client.id, then I want to return. Don't want to do anything. If it doesn't exist, then only I append to the client list. Okay, alright, I feel like I'm done finally. Okay, not yet done. Finally is the front end side, but front end side is very simple. I'm just going to add in a form so that it can, so this is from HTMX. So just go to the index.temper and in the top of my screen add in a form. So this form has this WS send attribute from the HTMX WebSocket that can trigger a message sending with additional payloads that you can see later. Enter. Alright, it works as intended. Whenever I press enter, it will then broadcast the message to everyone that is within that receive the that have the active connections like this. If I put in here, then broadcast to here 321. The second message 321 is broadcasted here. So any client will receive the message that I sent from one another, and that's the key point of our two-way communication here, where I have a manager in charge of handling the list of client list, and we have client in charge of reading and writing messages. Well, it is very lengthy and might be confusing at times, but I'll try to explain more on the concept along the way after this, as we touch more of the why in the future. But feel free to refer back to the code in the GitHub repository again, and to let me know if you have suggestions or anything, because I'm also pretty new in this area and still experimenting at different ways of implementing the WebSocket properly. Right, that's all for the sharing today. Thank you very much.